students. So now we will be studying about chain drive. So we have seen a chain drive. It consists of chain and sprocket. The sprockets are the wheels like this. This is a sprocket. Okay. There is another sprocket here. This type of wheels. Well, we can call them as tooth, some kind of a special kind of tooth. Each is cut here. The tooth wheel. And here we have a chain. Chain is just chain connects these two sprockets together. Now is it this chain here will be like we need to now have understood that this is a sprocket, and let's see how a chain what are the things that we see in a chain. So the thing is chain diagram here. So the first draw roller. This kind of roller is there. Okay, small rollers. This one. Okay. Another one. Right. Now, if we connect this solar to this solar using some kind of link like this, and that side also use that link. Okay. So, and we continue connecting similar type of rollers in the same manner. Here, another link like this. Okay. That side also one. So, this when we complete the connection, when we start from this side and we complete that side, then we will connect them to get all together. Okay, as a whole. That is called a chain. Okay, here in this diagram, you see these are called actually these are called chain link, LINK link. Okay? And these are the chain rollers. So we have seen a chain, elevated chain, seen bicycle chain, bike chain. Okay, so that is what we are talking about here. The drive chain that is used for driving. This see this kind of thing. You can see that if we have something like this, okay, something like this. This is also a chain. Okay? So you've seen that this is for tying or something, for lifting something. Okay? This type of thing is there. This is also a chain, but this is not for driving. Okay? That chain we don't use for driving. So here this is a chain drive. So now you can see the chain is a series of links connected by pin joints, and the sprocket is a tethered wheel with a special profile of teeth. So you have seen this. Now we can please go to the advantages. What other advantages are there for chain and disadvantages also. Now we need first of all we designate the chain with in this manner. Okay, with a number followed by a letter A or B. We can write this 8A. Okay, we normally do put actually 0 before this 08A. Okay, or let's say 16B. Okay, that way. I mean, this has to be 2 digit, and there is a letter after that. A or B. Okay, nothing else like C, D, E. We don't write that. With A and B. Now here we have this 2 digit letter, 2 digit number and a letter. So we need to see what is the meaning of this. So here, this is how the designation of chain drive uh, is done. So here you can see the designation of a chain drive consists of two parts: a number followed by a letter. The so whatever number we write here, that is actually something multiplied by 16. That means suppose we have 16A, then we have obtained this 16, this 16A is equal. This 16 value we have obtained by multiplying something into the number 16. So by multiplying something with 16, we have got 16. So what is that? The number that we have multiplied with this x is 1. So we have multiplied 1 with 16 to get 16. What if the number is 32? 32. This is the chain suppose. Then we have multiplied 2 with 16, okay, to get this number 32. So what we need to do is this number, that whatever we multiply with 16, 16 is a fixed number. Okay, we have to multiply something with 16 to get this. So what that something is called the pitch. Pitch. And that is in inches. Inches. You remember. So if we have a chain like suppose 32, okay, 32A, suppose 32A, then what we have to do, we have to divide this one by 16, and whatever we have here, that is the pitch value, 2 inches. So similarly, when we have 08A or 06, whatever we have, 08A, then the pitch will be 8 by 16, that is 1 by 2, 0.5. Then just divide this 8 by 16, that is 1 by 2. Okay, so pitch is 0.5 inches. Okay, so whatever value is there here, this value, okay, is divided, has to be divided by 16 to get the pitch. Okay, so here capital A means American Standard Series, ANSI. ANSI is a organization, and then B means British Standard Series. Okay. So all over world they follow these standards. So if this is the 08A, B, 16A, something, that means at the end we'll end this designation with A or B, capital A or capital B. Then before that we write 2-digit number. If it is a 1-digit number, then we'll put 0 before that. So you can see that 08B, it's a British standard chain. B is there. So 08 divided by 16 we have to do to get the pitch value. So this is pitch 0.5. And 16A, here you can see this is the its pitch value will be 16 by 16. Okay, this whatever value we have, that divided by 16, that will get us 1 inch. Okay, this is American standard chain. Now geometrical relationships in a chain. What we need here, first of all, we need to understand the pitch of a chain. So obviously, this is very simple thing. This is actually, see, these are rollers of the chain. One more roller, next more rollers, more rollers. All the rollers are connected by links. Links like this. So this type of links are there where rollers are connected. Now the links are not shown here. We have shown the rollers, and you can actually, if you measure the distance between the centers of each roller, that is called the pitch. This pitch. These are pitches. Okay. So, and you see that we, if we connect the rollers, see, this is a sprocket, right? Where all the rollers will fit into the empty gaps of this sprocket. Here, everywhere. We also everywhere. So here, what happens? This roller, okay, when it takes a turn or when it wraps around the sprocket, yes, you can see if you connect the centers of these rollers here in this manner, okay, this manner. So what happens? You get, if you connect these rollers like this, in that case, you will get a imaginary circle, one imaginary circle here. So this is called a pitch circle, and the diameter of the circle is the pitch diameter. Now, see, D is the pitch circle diameter, and here again we have an angle. Now see, this is if we subtend a line from the center of the roller to the center of the sprocket, and the next roller here, we subtend another line from that roller center to the center of the sprocket, then the angle made by these two lines is called your pitch circle. That is actually pitch angle. Pitch angle. Here also, if we subtend two lines like this, this is pitch angle. Here also between this line and this line we have the pitch angle. So this is here is pitch angle. An imaginary circle is drawn passing through the centers of the link pins of the chain, which is the pitch circle. Okay. Now, if the number of teeth on the sprocket wheel is Z, so you see, suppose 1, 2, 3, 4, how many number of teeth is there? So this alpha, okay, is actually divided by 360-degree total angle divided by number of teeth. Okay, suppose two number of teeth is there. Okay, 1 and 2. Okay. So we will have alpha between them. So if three number of teeth is there, how many angles will have? Is 360 divided by 3. Okay, it means actually you can see like this is suppose 5 are there. So this is 360-degree angle. So we'll divide it equally to 5 equal parts. 2, 3, 1, 2, 3, 4, 5. So this will be alpha. It's like that. So number of 360-degree number divided by number of teeth gives you the angle. Okay. This is not angle of wrap. Okay, don't get confused with that. That's a bad angle. This angle is called pitch angle. Next is if we just from this figure, if we take sine of alpha by 2, alpha by 2, 1 of alpha. So this much. Okay. So then we can actually nearly take this part as straight line. This is not straight line, this is curvature. Okay, actually there's a curvature of this, but since this alpha is actually small and the alpha by 2 will be more smaller than that, this part we take this as straight line. So we can take sine of alpha by 2. Okay, this will be perpendicular by base. Okay, so perpendicular by this hypotenuse. So this will be p by 2 by d by 2. Okay, radius from here to here is d by 2. Okay, and from here to here is this p by 2. So that is pitch by diameter. So a little bit more arrangement will show that this diameter can be written as p by sine 180 by z, because alpha is 360 by z. So 2 by 360 by 2 is 180. So this is one relation between pitch diameter and pitch and number of teeth. Again, this is a relation that we have learned from here. Okay, in gears, okay, in belt drive, everywhere. This is called the velocity ratio. Okay, higher speed divided by lower speed will be equal to inversely proportional to the number of teeth, okay, and the diameters. So here, if n1 is having higher speed, n2 is lower speed, then z1 will be z2 will come here, z2 z1 will come here. Okay, so here z is actually number of teeth. So the pinion, smaller sprocket, so the pinion, that part will have higher speed. Smaller sprocket has higher speed, and larger sprocket has lower speed. Okay, that you know. So n1, n2 are RPM, and z1, z2 are number of teeth. Okay, so this one is actually not very similar to gear, but sprocket is different. Okay, sprockets do not engage to another sprocket. Sprockets can get engaged with chain only. Next is the average velocity of the chain, velocity v equal to pi d n by 60 into 10 to the 3. So this is a relation that is given. So actually this we can get from equal to r. So in plus of omega, if you put 2 pi n by 60 and 2 into r is d, so we will get pi d n by 60. Okay. 10 to the 3 is there because we have written it as meter per second. Okay, because the diameter is in millimeter, so we have converted the diameter to meter. So this we have to divide by 1000. We always get this in meter. Okay. That's why 1000 is there. Now in place of pi d, we can write number of teeth into the pitch. Okay, because you see, let's see, this is one pitch plus 2p plus 3p plus 4p plus 5p, 6p, whatever number of teeth are there. So from here to here, one number of teeth. Next, one number of teeth. Okay, this will be total teeth is 2. This is third number of teeth comes. So this will be total teeth, that will be 3. Okay, first of all, maybe I missed this. So suppose the total number of teeth is z. So the total, the entire distance, that is circumference only, will be equal to z into p. Okay. So here circumference is pi into d. Okay, this is the 2 pi r. So 2 pi r equal to z into p from this sprocket. Okay. So we can write in place of pi d, we can write zp. So this relation is again very important. We can use this relation later. Okay. Equal to zp n by 60 into 10 to the 5. Okay, so one more relation is that here what uh, length of chain. Okay. Length of chain can be found by multiplying the pitch with something called ln. What is this ln? Actually, the number of links. Okay, number of links. So this again we can see if we have a chain here. So this is one number, suppose one. Suppose next one is 2, 3, 4, 5, 6. Okay, so the total number of links, this one, this plus, this plus, this plus, this plus, this, everything multiplied by the pitch. Okay, that means you can say that. But what will be the length of the chain? So from here to here is 1p. P is the pitch. So this will be 2p, 3p, 4p, 5p, 6p. It will go like that. So the total number of lengths, suppose from here to here is one link, next link, third link, fourth link, fifth link. It goes like this. Suppose n number of links is there. So suppose you can say, let's say 10 number of links is there. So one, if 10 number of links consist of suppose each of them is of length p, what will be total length? 10 into p, because 10 are there. That's right, 10 p. So here we have what? How many? Ln. Ln is just a number. It is normally it is an even number. It is a number of links. You see why this has to be even, because you see we have links in both sides of the roller. Okay, and both side has one of them. So obviously there are two, and if there is one more roller is there, then we have two more. So that's why there is an even number. Okay, because we cannot have only one-sided link. The other side will be open, and that will cause that will create problem, because that kind of thing we don't design, because here one side link is there, it is connected by only one link, that may break. Okay, because it must be connected from both the sides. That's why we have two of them. So each roller two of them. That's why the total number of link is even number. It has to be even. But the thing is, one more consideration is there. What if your calculation leads to an odd number? Okay. In design, we encounter such problems uh, many cases, because you see we're calculating only at the end. Okay, so you'll get an odd number. So how do we actually approximate to an even number? So here there's a rule actually. If you cannot approximate, okay, so your answer is an even odd number only. So what you do, you have to add one extra link yourself. Okay, and that link, if you add it now, it changes its strength and all these ratings, etc. So what happens for that purpose? What you have to do is you have to add a link to make the total number of links even. That's fine, but you cannot add one extra roller to that, because the other side will remain open, isn't it? So what you do, you have to overlap one link with another one. Okay, let me see. One roller has, let me show it like this. So there's another roller here. So we have a link connecting, two links connecting these two rollers. So one extra link has to be connected. So will it connect in this manner? No, we won't connect, because the other side will remain open. So we have an extra link. Where to put that link? So we will put it with the existing link only, just overlapping it. Now the thing is, here this side is having a more thicker, two links are there together. That side is having a very less amount of less thickness of the length. So at high speeds, it may cause problem. So what we do, the link that you add here has to be very thin, or we call it a weak link, weaker. Okay, that doesn't have much strength, but you must put it, because you may need to make it an even number. So this link, that additional link that you put is called, since it's weaker and this is not same as the link that you have put. This is not the same link that you have put with similar to other links. So this is called offset link. Okay, this thing I have written here actually. We read it out. This is the offset link. Whatever I say is written, go through them and you will understand. So here, one more thing. Now to find out the total length of the link, we can use this formula as well. But this ln, the number of links, you don't have to count. Okay, suppose you don't have the chain now, you are designing it. So before that, there is this relation. You have to follow this relation to find out what should be the number of links if you have already decided your pitch. So here this P is the pitch, Z1, Z2, you know, these are also number of teeth in both sprockets. Z1 is the number of teeth in the first sprocket, Z2 is the number of teeth in the second sprocket. And what is A? A is the center distance between the sprockets. Obviously there are two sprockets, here is one, okay, and there is another one this side. So we have a center distance. Now the thing is, just like your belt drive, you have an approximate center distance. Okay, your center distance, you just decide. You see, as a designer, you have to just you're designing at the beginning. You have to make decisions like what should be the gap between the sprockets. Okay, so you decide at gap first, center distance, and based on that, you just calculate it. If you see there is some, this is not sufficient enough, that it doesn't fit there, okay, then what you have to do, you have to modify. So that is what we do every time. So now see, this center distance is approximate center distance. That you have to first decide. Okay, but since here we are not going to repeat it, because actually that is the process. Actual process is first you assume it, then you repeat the calculation. That is how we achieve accuracy. But in numericals here, we will do it once only, because the numerical very lengthy in that case. So what you have to do, the center distances normally you have to decide, but it will be given in the question itself. Okay? Center distance is given, so based on that center distance, we calculate this length number of links. Number of links you calculate, then you multiply with the pitch to get the total length. So there is one more relation to actually calculate the center distance. See, this is a very long relation. You need to remember these relations, and also these kind of relations are available in data book. Okay? So design data book, you have to bring in your exam. And, you must bring it, because there are some data you cannot just remember. Okay? So those those kind of data you have to take, sit it yourself and set up. And sometimes it is handy when you get this type of relations also. Okay. So one more thing, you don't think that this relation is directly available. You have to see, you have to understand. Then you can actually take help of other relations, and then you can, if it is not there, you can derive it actually. So right now, I'm not going through the how the derivation etc. has come. That is not very important. So this is a relation. Okay, calculate the center distance. Now coming to the next thing, that is called chain strand. Strand. If I could share the screen, entire screen, let us show you one thing. Okay, just a moment. I can share it. So you can see the strand yourself. See, look at this. Single strand. Let me show you double strand. Okay, we have double, triple, strand. This is double strand. Okay. See, double strand. You can directly see. I taken so many. So you can see these are links. One link. Okay. another link that side. See, actually this is a continuous roller. Continuous roller. See, this is connected by two links here. Okay, the next two links will be outward. This is inward, the others will be outward. Okay, and since the roller length is very, I mean, this is a longer roller, we connect two more to this. Okay, and that's it, outer side. So you can see this is how we connect. So you can say that this is a continuous. See, here one sprocket will fit here. Okay, another sprocket will fit in that in this side. So this is called a strand, one strand. Single strand means there is only single chain is there. So normally the bike chains, bicycle chains, those are single stranded chain. Okay, we have this type of, this is called a strand. Okay, one strand, two strands. Let me show you triple strand. There's one more. If we have three of them, triple strand. So here is this is the triple strand. Search in Google, you can see the actual figures. So this is one strand, second strand, third strand. So normally we have up to three. Okay, but if a designer wishes, can have one more if required. So go back to sharing. So we have understood the strand. So we call a single strand. Normally we call it a simple or simplex. Okay. Simplex chain means there is only one strand. We have understood the strand. Okay. Next we have modern one means multiple strand. So we have duplex if double is there, and triplex if there is three strands. Okay. So it's like that. So in the next lecture I will continue this chain drive. Okay. And we'll see some numericals chain drive.